Alright guys, we are going to finish section 1.3 today, and we are going to look at the real number system. First thing I want to talk about is sets. And I don't know if you've heard of sets before, so I'm just going to kind of do an overview of this quickly. We are looking at sets because we can classify numbers using sets. We have a variety of numbers that we're going to talk about, and keeping the idea of sets in mind is going to help us organize all of these classifications. And first thing, what is a set? A set is a collection of objects. So maybe if you were to look in your silverware drawer, you would have a collection of objects. You may have spoons, forks, knives, maybe some other things. That could be considered a set. It doesn't have to be numbers, just a collection of objects. But of course in math we're going to use, for algebra purposes, a lot of numbers for our sets. Next, a subset of a set consists of elements from the given set. Okay, so if back to our example of our silverware drawer, if we had the collection of objects in our silverware drawer, a subset would just be a few pieces from the set. So maybe a subset would be just forks and spoons. Okay. And then one thing to note, we list elements in a set within braces, and those are going to be curly braces. They didn't write very well, but that's what those need to be, curly braces. One other thing as I'm looking at this, an element. What is an element? An item in a set we'll call an element. So if we're back at that silverware drawer, a fork is one element. A spoon is another element. A knife is a different element. So those, we're going to call them elements. Sometimes you think of items, but we call them element. So let's look at an example of a set using numbers. So I have an example set of 1, 2, 3, 4, and 5. Notice I have those curly braces there. A subset of that could be 1, 2, and 3. There are many more subsets that we could arrange. We could have a subset of 3, 4, 5. We could have a subset of just one of those numbers, so we could have a subset of just 1. But it just has to contain, the elements in the subset have to be contained in that original set. Okay, so let's keep that in mind. Moving on to real numbers, let's look at subsets of real numbers. And the first subset I want to look at is natural numbers. And natural numbers, think of those more of counting numbers. When you count things, you always start at 1 and then you go to 2 and 3 and so on. So our first subset is natural numbers. Our second subset is whole numbers. Whole numbers are going to be natural numbers and 0. So the only difference between natural numbers and whole numbers is that whole numbers has a 0. So we're going to start at 0, then 1, then 2, and so on. Next subset is integers. We can think of these as natural numbers, their opposites, and 0. Sometimes you can hear the definition of integers as positive and negative whole numbers. Kind of works, however, you can't have a negative 0. So I really like this better. Natural numbers, their opposites, and then 0. So integers, the dots before the -3 mean you continue forever in the negative direction. -3, -2, -1, 0, 1, 2, and 3, and so on. Okay. Next set of numbers is rational numbers. Rational numbers, this is going to be any number that can be written as a fraction of integers. So some examples of that are 1/2, 3, -2/3, 6.7. Okay, we're going to spend some time in class looking at these subsets, and really we're going to look special attention what makes a rational number. So if you have questions, if you're not sure, we are going to clarify that up. So maybe jot down a question and I will address that the next day. Our last subset of real numbers is irrational numbers. This is going to be any number that cannot be written as a fraction of integers. Examples of these are pi, square root of 2, And really, any square root of a number that is not a perfect square root is going to be considered irrational. And then any decimal that just continues, doesn't stop, doesn't repeat, is considered an irrational number. So a number, if it'll either be rational or irrational. It can't be both. It'll be one or the other. So 1 can be written as a fraction of integers. 1 cannot be written as a fraction of integers. Okay, so let's look at some examples. Which subsets of the real numbers does each number belong to? And our first number that we have is 15. So look back up in your notes. I'm going to start with a natural number. Is it a counting number? Well, 15 is a number that you would count to. So the first thing I would write down is that 15 is considered a natural number. And I'm just going to write natural. We don't need to write natural number after each. Is it a whole number? Well, whole number we wrote behind is natural and 0. Since it is a natural number, it is also considered a whole number. So I'm going to write down whole. Is it an integer? Well, again, behind integer is natural numbers, their opposites, and 0. It is a natural number, so it is also an integer. Is it a rational number? Can we write it as a fraction of integers? Well, reminder, if you have any whole number, you can always put it over 1. So if I write here 15 over 1, I can write that as a fraction. So 15 is also considered a rational number. And reminder, if something is rational, it cannot be irrational. So we are out of subsets, and 15 then qualifies as 4 subsets of real numbers. Okay, let's look at one more example. Square root of 57. Is square root of 57 a natural number? No. Double check that your square root can't reduce. If it's a perfect square, think of it as the perfect square. So if it said instead the square root of 64, I would like you to think of that as 8. However, square root of 57 is not a perfect square. So it's not a natural. It's not a whole number. It is not an integer. And then, is it rational or irrational? Well, we're not going to just put it over 1. That's what we're going to do if it's a whole number. Look at what we have written for irrational numbers. An example for irrational numbers is the square root of 2. And if you can remember, I said square root of 2 stands for any square root of a non-perfect number, non-perfect square. This is an example of that. So the subset that the square root of 57 would fall under would be irrational number. It only falls underneath 1. If you are confused with this, we're going to spend a lot of time the next day just looking specifically at these. Hopefully, somewhat review, somewhat new information with the rational and irrational number. Okay, let's look at a quick recall of inequalities. There we go. There we go. Recall of the inequality symbols. First symbol I have there is less than. Directly below it is greater than. Next column, less than or equal to. Finally, greater than or equal to. Okay, you're going to have to compare, and really this is a review. When you're comparing, anytime it says compare, you're going to think inequality symbol. Now, if two numbers are equal to each other, then you're going to put in the equal sign. But if not, we're going to use an inequality symbol. First number I have is square root of 13. Think, between what two numbers does the square root of 13 fall in between? Well, it falls in between 3 and 4. Because square root of 9 is 3. Square root of 16, oops, there we go, is 4. Square root of 13 falls in between there. So since it's going to fall in between, it has to be less than 4. So we're going to put in there the less than symbol. Okay. If you have a fraction when you are comparing, you may have to divide and write it as a decimal in order to compare. You'll just have to make that decision depending on the problem. Okay. And then our last item that I want to cover here, there we go, is ordering real numbers from least to greatest. To be able to order numbers, you have to be able to compare them, so that's why I stuck in an example of that. Our numbers that we're going to order is the square root of 4, 3/10, square root of 2, and 1/3. Okay. Due to some scratch work, I'm going to write this underneath. I'm going to simplify any square roots that are possible. Square root of 4, that is 2, so I'm going to write 2 underneath. 3/10 I can't simplify. Square root of 2, well, that falls in between 1 and 2. Okay. 1/3, if I were to write that as a decimal, reminder that's going to be 0.3 repeating, which if I write out a first few digits, it's going to be let's see if my pen works, there we go, 0.33333, and so on. So once I've kind of got a feel for what my numbers are, I can now put them in order from least to greatest. So my smallest two numbers are going to be 3/10 and 1/3. Okay. Well, if I'm comparing the decimals, reminder I wrote underneath 1/3 the decimal, 3/10 is going to be smallest. So off here to the side here, I'm going to write my answer. Okay, so I have 3/10. My next smallest number is going to be 1/3. Whenever you're ordering these, you always want to write the number in the original form. So I'm not going to write it as the decimal, 0.3 repeating. I'm going to write it as the fraction, 1/3. Okay. The next two numbers I have are the square root of 4, square root of 2. Since the square root of 2 is in between 1 and 2, it's going to be less than 2. And we said the square root of 4 is 2. So my next number I have is going to be the square root of 2, followed by, there we go, the square root of 4. And remember, don't write that as 2. Write it in the original form, which is the square root of 4. You will receive points deducted if you do not write your answer using the original form. Okay, and that's all we have for notes today. I do apologize that it was a little bit longer than usual.